Hello, Physics MT8A part. The question is a transformer with 100 turns in primary, 100 volt, 2.4 ampere. How many turns in secondary is required to supply 4.8 A? So the double of the ampere from the primary. So the power remain the same. So the power in the primary Vp over into Ip is equal to the primary's power Vs into Is. So if you primary uh, voltage and current is equal to the voltage in secondary into current required, which is this one. So voltage in secondary should be 50 volt. So 50 volt in secondary and 100 volt into primary. So the voltage in primary is proportional to the number of turns. So it's a double of the voltage to the double of turns, so which is equal to uh, 50 turns in secondary, half of the turns. So Vp over Vs is equal to Np over Ns. So Ns is equal to Np over Np into Vs over Vp. So Np is 100 over, so 100 into voltage in secondary. Voltage in secondary is 50 over 100, so 50 turns in secondary. So question number 2. A radioactive sample containing two different isotopes A and B has the half-life of 3 days and the B have 6 days. Initially, isotopes have the same has a twice. Initially, the sample has twice as many of A as B. What is at what this ratio? What time this ratio will be reversed? So from double to half. So initially 3 days, 6 days, and 9 days and 12 days. This one initially AB 2A into B, and this will be half into the first one will be half in A has half life of 3 and uh, 6 days B. So initially, and uh, this will be A by 3, and then this will be A by this will be half, this will be A, this will be A, and then 6 day A by 2, and then A by 4, and then A by 8. And this one is 6 days. So after 6 days, it will be half, and to 12 day, it will be 4. So this will be at 12 day, A8 and A4 multiplied by 8. So this will be reversed at 12 days. Question number 3. Equivalent resistance in a network. So we have to find this one. So first parallel, and then series, and then parallel. So we have to find this one. So AB, CD, EF, and GH. This is the combination. So AB, so this AB will be reduced to half, and CD is a double. EF will be look like this one to 2R into this one, and this one will be equal to, so uh, uh, 2R multiplied by R into sum of this one. So 2R square by 3R, so 2 by 3R. So this is EF. So top is half, and this is equal to 2/3. And then it will be in parallel. So this will be combination of this one and add them together. So this will be R square by 3, and then add them together. So 3R plus 3R. So 3R plus 4R by 6. So this will be R squared by 2 uh, divided by this one is 6 by 7R. So this will be equal to, so 3 by 7R. So this will be the answer of this one. Next question. Next question is a satellite, two satellite, one in a geostationary orbit and other one is half of that of the first one. What is the period of the second one? The first satellite, second, first is geocentric, geostationary. That's, I mean, it has a time period of 24 hour, and this one is half of the radius, so that we have to find this one. Kepler's law. So the Kepler's law is that uh, time is square is radius a cube. So this will be T1 over T2 whole square is equal to R1 or R2 raised power 3. So T2, we have to find T2 is equal to T1 into R2 over R1 whole cube. So if you substitute this value, so this one T1 is a 24 hour. R2 our R1, R2 is half radius, R1 is the R geocentric, exactly uh, at the from the surface is the center of radius of the earth. So this one and this will equal 72 hour square root. This will be 8.5 hour time period of the second satellite.